Hello friends, today's question. 7 identical circular planar discs, each of mass m and radius r, are welded symmetrically as shown in the figure. The moment of inertia of the arrangement about an axis normal to the plane and passing through the points. So these are 7 identical discs. We will find out the moment of inertia of all the discs about an axis which is normal to the plane and passing through point P. In this case, we are given 7 discs. Let us name them. Disk number 0, and 6. One by one we are solve it. Let us consider and this is our disk 0. Now let me, it will be this, and this point is O. So we are going to find the moment of inertia of this 0 around point. Moment of inertia about point O will be given as its radius is and mass is m. The moment of this about point O will be given as half mr square, and we are supposed to find out that normal to the plane. So we consider that the axis is normal to the plane and going into the plane, so represented by a cross. So in this case also we find out the moment of inertia about the axis which is perpendicular to the disk. So let me write it here. Point O about the axis perpendicular to the plane, which will be given as and passing through point O. So this will be given as mi0 will be equal to half mr square. Now let us consider another disk. I suppose that is disk number 1. Considering disk 1. Now we already have disk 0. This is disk 0, and this is our disk 1, and the distance between their centers will be 2r. In this case, once again we are going to have the moment of inertia. This is also into the plane, and here also into the plane, which are both into the plane and therefore they will be parallel to each other. Considering this 1, we will say moment of inertia of this 1 about the axis which passes through point O. Passes through point O. So there are two axes. One is this one, which will be also into the plane, and this 0 which will also into the plane. So therefore we are going to use theorem of parallelism. discuss the theorem of parallel axis. That moment of inertia of this 1 about 0 is equal to moment of inertia of this 0 plus moment of inertia of this 1, that is half mr square, plus moment of inertia of this 1 about 0 of this one. This will half and m 2r whole. This is our this 0 and this is this 1. And similarly, you can find out for all the disks. Similarly, you can find for remaining disks, that is 2, 3, 4, 5 and 6, and in combined form that is all their moment of inertia as moment of inertia of system. You see, in the combined form the total moment of inertia about 4 is our system about 1. Therefore, you can write it as our system will be equal to system about 0.4 will be equal to moment of inertia of at 0.4, and this will be now we have now 6 disks, so this will be 6 multiplied by half mr square plus m whole. Substitute the value, we get this as half mr square plus this will become as 3 mr square plus this will be about 24 mr square. Therefore, we get this as I system at 0.4 will equal to 55 mr square kilometer cube. So we found out the moment of inertia of all the disks with respect to 0.4. We found out the moment of inertia of all the disks with respect to 0.4. So 0.4, and this is our I system. System with respect to O. And we are supposed to find out the moment of inertia at point P. From this distance will be now 2r. Once again, this is into the paper and here axis also into the paper. So now once again these are two parallel axes. You can use the theorem of parallel axes in order to solve it. Therefore we can say moment of inertia about point P will be shifting the entire moment of inertia point O to point P. Therefore, we can say that moment of inertia about point P will be equal to moment of inertia of our system about point O plus m, and this will be distance is 3r square. In this case, as we shifted the moment of inertia of all the masses to this point O, so at this point O we have a total mass of 7m. So this term will be multiplied by 7. We know the simple calculation. The system O we already know is 55 mr square divided by 2 plus this will be about 763 mr square. So we get our moment of inertia about point P will be coming equal to 181 mr square divided by this is the moment of inertia of the system about point P. This is moment of inertia of the all disk about point P. So check the option available with us is our option A is the correct option. Say option A is correct. Here I forgot to mention that using theorem of parallel axis. Theorem of parallel axis. Now in this case there is a little bit might be confusion how the disk one is having a, you can say, summation of, so how the overall moment of inertia of disk 1 with respect to point O, it is normally having, or normally it has only the, in the parallel axis, it is summation of only two terms, that is moment of inertia of the about the axis about which we know the answer, and plus the mass into perpendicular distance. But in this case we have a extra term, that is half mr square. So we can show it something like this. So we already know that this is a disk 0 whose moment of inertia is given as half mr square, and we have a disk 1, and first of all we are going to find out the moment of inertia of this disk 1 about its center. So if we find out the moment of inertia of disk 1 about its center, it will be coming as half mr square. Now this is our disk 1, so this is our now disk 0, which is having a moment of inertia of half mr square, and this is our disk 1, which is having a moment of inertia of half mr square. Now we are going to shift or find out the moment of inertia of disk 1 about disk 0. From here, now this distance is 2r, and its mass is capital. So the moment of inertia at point, now we are going to get this as mi of 1 at point 0 will be equal to moment of inertia of disk 0 plus moment of inertia of disk 1 and plus the parallel axis theorem, that is equal to m and this will be 2r whole. this simplifies a little bit how this is with respect to the disk 0 and this is with respect to the disk 1. We are going to find out the moment of inertia of the disk at its point, and then we are going to shift it. Okay. So this gives us disk 1 is half mv square, that is moment of inertia of the disk 1 itself plus according to the parallel sector. This concludes the question.